All right, hello. Today I'm just going to talk to you about equations and how points connect to equations. This is one of those fundamental pieces of information that once you know, it can connect a lot of dots, and it helps to make everything else understandable, and it provides a background so that you're not just memorizing a shortcut or something like that, but you actually understand the underlying reasons behind things. So we can start off with a very basic equation, something like y equals x. And when you have an equation like this, the points that this equation connects to, the points that come from this equation, satisfy this equation. So this equation is pretty simple. It just says that the y is equal to the x. Points usually come with an x and a y. So the points that would be a part of this equation would be ones where the y equals the x, where these two would be the same. So stuff like 0, 0, 1, 1, -1, -1, 5, 5, stuff like this. The y equals the x, and so that would match up with this equation. As you get more complicated equations, you add more steps to it, it becomes a little bit trickier to check to see if points match with the equation. So like this one says y equals double x, y equals 2 times the x. We can see that something like 3, 6, right? The y is double what the x is. This would be a point that fits on this equation. Something like 10, 5, right? -20, -10, something like this. All these points satisfy this equation here. Now, as you get more complicated and towards the types of equations that you would do in Math 2, something like y equals x minus 5 squared plus 9, it becomes a little bit harder to see instantly which points match these equations. But there's a strategy that's really useful, and it works almost all the time for every possible equation. And that is to set one of the values. So you can either set the x or the y. Setting the x tends to be easier. But you set the x, and then you kind of you simplify one of the sides of the equation, and you don't write what the y is until you actually know what it is already. So for instance, let's say that I pick 4. I could write the equation where x is 4. So I'm just going to copy this equation down, but I'm going to put 4 instead of x. Something like this. And I'm just going to simplify this using the order of operations. You might remember as PEMDAS. So parentheses means we're going to get -1. Exponents means we have -1 squared, which is +1. 1 plus 9. We can skip multiplication division since there's none of those. Addition gives us 10. And so we end up with y equals 10. So we chose x to be 4, and at the end we got that y equals 10. And that corresponds directly to the point, x and y. And this point is part of this equation. This is the basis and the foundation for how points connect to equations and how functions work in regards to graphs. You can actually graph this equation entirely by just picking different x's, simplifying them and figuring out what the y is. That'll take a little while. It's time consuming, but it'll work, and you'll get as long as you are simplifying correctly, you'll get the correct points. The next step, once you understand this, is to start to develop an understanding of which numbers lead to significant points. So I picked 4 here, but by picking more important numbers like 0 for here, or 0 for here, or maybe 5, because there's a 5 here, by choosing numbers strategically, I can find the points that I want to find. Like I can find the vertex, I can find the intercepts. But it's all based on this idea. And so this is the idea of points as they connect to as they connect to equations.